Alright, so we're going to move into the laws of exponents, which is a little bit of a review of Algebra 1 and Algebra 2. Okay, so we're going to review some of the laws. So on here we have our law number 1. So when you're multiplying two numbers with the same base, this is considered a base. Okay, so when you're multiplying two numbers with the same base, all you got to do is add up those exponents, so m plus n. Okay, when you're dividing, okay, you need to make sure they do have the same base, or the same number. You're going to go ahead and subtract. Okay. Then from there, let me see. When you have it in parentheses, A and B, and you're trying to put it to the power of an exponent, you do have to distribute that exponent to each one. Okay. The same thing with division. You have A over B, and you have an M outside the parentheses, so you do have to distribute. Okay. So what happens if the thing that you have in here in parentheses already has an exponent, okay? And you want to put it to another power of an exponent. Well, in that case, that's when you would multiply the exponents. And then last, any number, okay, except for 0, it tells you here. So any number, 1, 1,000, 1,000,000, -7, -567, when you put it to the 0 power, it will always give you 1, okay? So let's go ahead and run through this. It says simplify. So we have 3x squared y. We want to take all of that and put it to the power of 2. So we're going to have to distribute that exponent to each one. Okay, so 3 gets to be put to the second power. Now x squared already has an exponent, so then that's when we have to multiply 2 times 2. And then the last, the y doesn't have an exponent, so it'll just be y squared. So I'm going to simplify this. 3 to the second power gives you 9. And then x, 2 times 2 gives us 4, y squared. That's it. Okay. The next one, so here we have division. Now numbers don't have these new rules, okay? The numbers, the coefficients in the front, they just do regular operations. So 12 divided by -4 is going to give us -3. But the exponents, remember, they do have different rules. So it's a to the 7th power and a to the 3rd power. What we got to do is subtract the exponent. So 7 minus 3 gives us 4. All right, the next one, it says 2 times r to the 3rd power s to the 5th power is to the 0 power. So this whole thing is to the 0 power. Remember, anything at all to the 0 power gives you 1. All right, the next one, here we're going to start off by looking at the coefficients. So my coefficients are 2 and 6. Now we can't take 2 and divide it by 6 and get a whole number, but what we can do is simplify it. So it gives us 1/3 when we simplify. Okay, then we look at the x's. So here I have x to the 7th power and x squared. So what we got to do is subtract the exponent. So 7 minus 2 gives us 5. That is going to go on the top. Okay, now on the bottom, I don't think this rule was on there. But on the bottom, we have y and y to the 3rd power. So when I do 1 minus 3, that gives us -2. 1 minus 3 gives us -2. So then that means that the 2 is going to go on the denominator, the y squared. So let me show you why real quick, why this happened. So for example, for the x, we have x times x times x times x times x, 1, 2, 3, 4, 5, 6, 7, and then we only have one y at the top. Okay, and then of course we have the 2 and the 6 on top. On the bottom, I have x times x because it's x squared, and then y to the 3rd power. So y times y times y. Okay, so then when we start canceling out, these two cancel each other out, these two cancel each other out. So we're left with 1, 2, 3, 4, and 5. X is on top, so x to the 5th power, which is what I have here. Okay, and then on the for the y's, this y will cancel out with one of these y's, and we are left over with 2 y's. So that's why I have this y squared here on the bottom. So I hope that kind of explains why I put the y on the bottom and I didn't put a negative on there. All right, the next one. So here we have 3 over 2, x to the 3rd, 4y squared. Okay. So let's just start with the regular numbers first because they have regular rules. They don't have special rules. So we're going to go ahead and take 3 times 4, which gives us 12, and we divide it by 2, which gives us 6. So the 6 would go on top. Okay. Then let's go ahead and look at the coefficients here. So I have x to the third power and x to the eighth power. We go ahead and subtract. 3 minus 8, that gives us negative 5. So that means that the 5 is going to go on the denominator, x to the fifth power. Then we go ahead and look at the y. So on the bottom I have y to the fourth power, on the top I have y squared. So when I do 2 minus 4, that gives me negative 2. So then that means it's going to go on the bottom as well. You don't have to put the negative because we did move its location. I'm going to move this 6 to the middle. And there you go, that's it. The next one, so here we have a to the fourth over b squared. So remember the rule is to distribute the 2 to each one. So then from there, a to the fourth squared is going to give us a to the eighth over, and then we're going to have b squared times. Okay, so we have this here. And then we are going to have to distribute this 3 to each one. So this gives us a to the sixth power times b to the sixth power. Okay, so then from there, if you notice, we have these two in common, the a to the eighth and the a to the sixth power. So when we multiply those, a to the eighth and a to the sixth, that gives me a to the 14th power. Over, well, let's see if we even have anything there. Next, we have here b to the sixth power on top and b squared on the bottom. So then the rule is we have to subtract the exponent. So 6 minus 2 gives me 4, and it's a positive 4, so it is going to go on top. So I'm going to go ahead and erase this line because we're not going to need it. Everything landed on top, and that's it. Okay, so here's the negative rule, which is what we just went over. A negative exponent does not indicate a negative number. Okay, so whenever the exponent is negative, it just means it's in the wrong location. So for example, if a to the negative n is right here, you need to move it to the denominator and change the sign, and that'll tell you that it's in the right location. Now, if it's backwards where the exponent is on the bottom, for example, here on number 8, do you see how the exponent is negative on the bottom? That means that it's in the wrong location. You need to move it to the top and change it to a positive. Okay, so let's go ahead and solve some of these. All right, so right off the bat, I do notice that this is y to the power of negative 3, so I'm going to rewrite it real quick. I have x squared, and instead of writing on the top, it needs to move to the bottom, and we change the sign. It turns to a positive. So now we're going to simplify this. Y times y to the third power. Remember, there's an invisible 1 here. Okay, it's understood that that's y to the first power. We just never write it. So y to the first times y to the third gives us y to the fourth power, and that would be our solution. All right, the next one, xy to the fourth, and then on the denominator, we do notice that x is to the power of negative 2. So that just means it's in the wrong location. So we're going to have to, we have xy to the fourth power. We're going to move it to the top with the x and the y to the fourth power, and it's to the second power, and it'll be positive. We simplify, this is x to the first power and x squared. When we combine them, it gives us x to the third, y to the fourth. Number 9. Okay, so this does tell me that it is in the wrong location, but first, I am going to distribute this negative 2 to each one. So we end up getting 5 to the power of negative 2. X, 4 times negative 2 gives me negative 8. Remember, when you have a power to another power, you multiply. And then y to the negative 3, negative 2, that's going to give me y to the positive 6. Because when you multiply negative 3 times negative 2, it gives us positive 6. All right, so then these two that we see with the negative exponent, we're going to have to rewrite it in the denominator. So on the top, I have y to the 6. On the bottom, I have 5 squared x 8. Okay. The y to the 6 has nothing to combine with. The x to the 8 has nothing to combine with. But we can get 5 squared. 5 squared gives me 25, so that'll be the coefficient of x to the 8th power. All right, moving on. Okay, so the last section, we have law of B is P over Q, where the cube root of b to the p power or the cube root of b to the p power. Okay, so real quick, I know that sounds super complicated, but it's not too bad. So for example, the square root of x okay? The square root of x, we can rewrite the square root as a fraction. The way you rewrite it as a fraction is x to the power of 1/2, okay? Where the 1 comes from, right here, is the exponent of x, okay? Now the exponent of x here is 1. We usually don't write the 1 there, but it's understood that that's x to the first power. And then the 2 comes from the square root. You know how square root is the opposite of squared? So that's where it comes from. Okay, so for example, if we had the cube root of x squared, for example, okay, we would have x to the power, since it's squared, the 2 would go on top. And then since you're taking the cube root, then the 3 would go on the bottom. So it'd be 2/3. Okay, so that's what this is saying, okay? So for example here, we have x, and then this is the square root. So I'm going to rewrite that as to the power of 1/2 times. This one is a cube root. So it's x, because x is to the first power, it's 1/3. And then the next one, since this one is the 6th root, then it's going to be x to the power of, our x is to the first power, so it'll be 1/6. All right, so if we're multiplying all of these, the rule is we add the exponents. Okay, so in my calculator, what we're going to do is we're going to do 1/2 plus 1/3 plus 1/6 and see what it gives us. And I believe it gives us 1, x to the first power. And that's it. All right, so on here, this time I have x, it's a cube root of x. So I'm going to rewrite this as a, so I'm going to leave the outside the same, but the cube root of x, this part right here, I'm going to write it as a fractional exponent. So x to the power of 1/3, okay? Then we have x to the power 1/3 to the 5th power. So when you have a power to a power, you have to multiply them. And when we multiply them, that gives us x to the 5/3. All right, so then the same thing with this one. We have all of this in parentheses, and it's a cube root. So remember the cube root, we have all of this is to the 4th power. So then this part, 27, a to the 6th, b to the 3rd. Since it's all under the cube root, I'm going to put it all to the power 1/3. Okay, so I'm going to do the part inside the parentheses first. So I'm going to put each one to the 1/3. So 27 to the 1/3. A has a 6th power, so we're going to have to multiply. Remember, we have a power to a power, we multiply. And then b to the 3rd times 1/3. And don't forget, all of this is to the 4th. But we'll wait for us to simplify this first. So 27 to the 1/3, remember, that's like taking the cube root of 27, that gives us 3. 6 times 1/3 gives us 8 to the 2nd power. 3 times 1/3 gives us b to the 1st power. And remember, all of this is still to the 4th power. Now I'm going to go ahead and take all this and put it to the 4th power. So I'm going to go ahead and multiply all those. So 3 to the 4th power is going to give me 81. A squared to the 4th is going to give me 8 to the 8th power. And b to the 1st power times 4 is going to give me b to the 4th. And that's it. Thank you guys. We'll see you guys next time. Bye.